Hi everyone. So I'm going to go through question 6 on power. So that is from this page, and so I've made two separate videos, one on question 5 and one on question 6. Now question 6 is about what's called potential dividers or voltage dividers. So let's go through this together. Okay, so in the circuit shown, R1 and R2 are each variable parts of a total resistance of 15 ohms. That means R1 and R2 together at all times add up to 15 ohms. What you can do is change their resistances individually, but at any point of time, these two together add up to 15. Okay, so R2 is set to 5 ohms. So this is the first part of the question. So if this is 5 ohms, then R1 is going to be 10 ohms. Okay, right. Now you've got a lamp, 2 ohm lamp in parallel with R1 at all times. Okay, the first thing we need to do is calculate the total resistance of the circuit. So just like we did earlier, you first have to find this total resistance of this parallel part and then add it with this. That'll be in series. Okay, so RT in parallel, so this parallel bit is 1 over RT, which is equal to, now that's 10, so 1 over 10 plus 1 over 2. So your total resistance, you know, is going to be less than 2, right? It's always less than the least. Plus 2 to the power of negative 1. Okay, let me just put that in my calculator. What do we get? So open brackets, and you get 10 shift negative 1 plus 2 shift negative 1, close bracket, negative 1, and I end up with 1.67. So that's the resistance of just those two together. And then total resistance of the whole circuit is, now that's at 5, right? So 5 plus 1.67, you get 6.67 ohms. So that's the total resistance of the circuit. The next one, B, is calculate the current from the battery. So the current from the battery depends on two things. It depends on the total resistance and the battery voltage. So can you see if we're right at the bottom? You can. Okay, so I is equal to V over R. So V is 20 volts and your resistance is 6.67 ohms. So your current from the battery is 20 divided by 6.67, and you get about 3. You get 2.998 amps. So I'm just going to write that as 3 amps. Okay? Right. Okay. Then calculate the power output of the battery. So power output of the battery depends on the current as well times the voltage. So power output, just checking to see if you can see. So power is equal to voltage times current. Yeah, you can kind of make out. Voltage is 20. Your current is 3, so 20 times 3 is about 60 watts. Okay, ideally you get 59.9 something. It's very close to 60. Okay, calculate the voltage across R2. So voltage across R2 is the current through R2. So voltage is current times resistance. So I'll just do that over here next to it. So current is 3 amps. So all the 3 flows through it times 5. So that is 15 volts. Okay. Then calculate the current through the lamp. So in order to calculate the current through the lamp, I'll just rub up this bit because my board is really small. Current through the lamp is, if that is 15 volts and the total is 20 volts, the voltage across that is 20 minus 15, that is 5 volts. So the voltage across that and the voltage across that is 5 volts each. So current is voltage over resistance, so that's 5 over 2, which is 2.5 amps. Okay, right? Because that's least resistance, right? So biggest current through there. Okay. Calculate the power output of the lamp. So if you know the current through and the voltage across, then you can calculate the power output of the lamp. So this is part F. So power is voltage times current. Your voltage is 5, current is 2.5. So that's 12.5 watts. Okay. And then calculate the light energy supplied by the lamp every hour. So this is G. So that's the other formula for power. Power is energy over time. So energy is power multiplied by time. And you know the power is 12.5. 1 hour is 60 minutes, which is 60 seconds. So you've got to multiply all those together. And you're going to get 12.5 times 60 times 60, and I get 45,000. Okay, so, and it's energy, so it's going to be in joules. Now then what happens is R2 is reset to 10 ohms. So all this changes. So that becomes 10 ohms. So if that becomes 10 ohms, that means this is only 5 ohms. So what's going to happen? So what's going to, and this one was 2 ohms, right? Okay. So if R2 is reset to 10 ohms, it says what happens to the brightness of this lamp. So what do you think is going to happen to the total resistance of the circuit? So that's 10, and the total of this, the resistance in parallel, so let's reason this out, is 1 over RT is equal to 1 over 5 plus 1 over 2, or your RT is 5 to the power of negative 1 plus 2 to the power of negative 1. So you get open brackets, 5 to the power of negative 1 plus 2 to the power of negative 1, close bracket, to the power of negative 1. I get 1.42. So that's 1.42 ohms. So your total resistance is 10 plus 1.42, which is 11.42 ohms. So what's going to happen? So 11.42 ohms is, that means the resistance of your whole circuit is going to increase. That means the current is going to decrease, right? Okay, so you're going to have a smaller current through here, and so that lamp is going to get dimmer. All right, so there's going to be a bigger voltage across that. So that means the voltage across this proportionally is going to be less. And so the current, it's going to get dimmer. Okay, bye for now.